Today, I will show to everyone how forward and reverse bias circuit work. First, let me show all the components that I'm going to use. This is diode, resistor, LED, jumper, power supply, and breadboard. As we know, most of the components have polarity like diode and this LED. For diode, there is silver line to show the negative side and the other part is positive. This LED has one short leg which is negative and one long leg that is positive. But as for resistor, it doesn't have polarity, so that we can just put it arbitrarily. For the breadboard, this side, the current flow vertically, while for this side, the current flow horizontally. For the first circuit, I will connect this diode according to the forward bias. Put the diode, start with positive terminal. Use the jumper to connect it with the resistor. After that, put the resistor arbitrarily to the jumper. Then, connect the resistor using the jumper to the positive terminal of the LED. Next, put the positive terminal of the power supply to the positive terminal of diode and the negative terminal to the negative side of LED. Ta-da! The LED will lighten up. For reverse bias, I just change the position of this diode. Then, put the positive terminal of the power supply to the diode and the negative terminal to the LED. There is no light from the LED. This means that current only can flow through the forward bias circuit, while it's only allowed extremely small current in reverse bias circuit that it can be neglected.
Now, we will go through the voltage current characteristic of a diode. VI characteristic for forward bias. When a forward bias voltage is applied, there is a current called forward current. In this case, with the voltage applied is less than the barrier potential, so the diode, for all practical purposes, is still in a non-conducting state. Then, the current is very small. When the forward bias voltage increase, the current also increase. With the applied voltage exceeding the barrier potential, that is 0.7 volt, the forward current begins to increase rapidly. But the voltage across the diode will increase only gradually above 0.7 volt. This is due to voltage drop across the internal dynamic resistance of semiconductor material. The graph shows the forward voltage will increase to the right along the x-axis and forward current will increase upward through the y-axis. After 0.7 volt, the voltage will remain at 0.7 volt, but forward current will increase rapidly. Hence, the normal operation for a forward bias diode is above the knee of the curve. VI characteristic for reverse bias. When a reverse bias voltage is applied, there is only an extremely small reverse current through the PN junction. In this case, when the reverse bias voltage increases, there is a very small reverse current. Hence, the voltage across the diode will increase. The graph shows the reverse bias voltage increase to the left along the x-axis, while reverse current increase downward along the y-axis. When the reverse bias voltage reach the breakdown bias, the reverse current begin to increase rapidly. As the reverse bias voltage continuously increase, the reverse current will continue to increase very rapidly. But the voltage across the diode increase very little above the breakdown bias. And then, this is the combination of forward bias and reverse bias complete VI characteristic curve.